Boolean types. Okay, so the type Boolean, Swift has a basic Boolean type. It's called bool, which it can store only two values, true or false. In math, bool is the person that actually invented that. It's usually sometimes when you ask a question that you can answer by yes or no, or true or false, this is usually a Boolean answer. Okay, so for example, planet Earth is blue, and we put equal true because yes, it is true. The planet Earth is blue. Now, planet Mars is yellow. That's false. So we put equal to false. Then var planet Jupiter is blue. Is blue. We force it to be a bool, saying that yes, the value can only be true or false. Okay. So in the first one, we set it to true. In the first two examples, you can see that we did not say bool. And what's going on is that the system or the compiler, and I'm going to explain you in the near slides what a compiler is. But the system, the program, is understanding that we are using Boolean here. That can only be true or false. Now, nil type, question mark, and exclamation point symbols. So, Swift can represent a value that has no value, right? Sometimes you need a value that has no value. It's called nil. Okay, and here is an example, var, classroom student count. So we're counting the number of students, and we put it's an integer with an exclamation point, which means that it has no value yet. So if we print the value of this classroom student count, it's gonna be nil at first. Why? Because we did not set any values. Okay, so we did not say is equal to 10 or is equal to 20. So automatically the value is going to be nil because we did not write any values there. So let's now say what the compiler is, because the compiler is the one that says that if it hasn't been set, then it's nil. So the compiler, it's the computer program that will transform the source code written, with basically whatever we're writing in the Xcode language, in the language Swift, and it's transforming this into a language the computer can understand. And that language is binary, or chunks of binary string. For example, 010110000, this is a chunk of binary string. Now, whenever you write something like this, classroom student count int, this is only one instruction that you write. It's only, here we're actually writing two lines. But when these two lines are translated, they're translated into chunks of 0 and 1s. Now, you probably will think, oh, it's only two instructions, so it might be two chunks of 0s and 1s. Absolutely not. These two lines are actually probably hundreds, if not thousands, of binary string for the computer to understand what to do there. But don't worry about it. Nowadays, computers, especially iPhones, can handle probably almost billions of these chunks in a second. Okay, so this is the clock or the frequency. You guys have probably heard about frequencies of a CPU, 1.2 megahertz, 3 gigahertz, and so on. These are the number of transactions per second, okay, or instructions per second. And final slide here, the question mark symbol at the end of a type. It's called optional, which means the variable's value is optional. Nil is nil if not set. So if you do not set the value of, let's say, survey answer, you do not have any value yet. If you put a question mark at the end, it will automatically set it to nil. Okay? So as you can see also, the variable lottery winner name string with a question mark is equal to nil. Here we're forcing it to be nil. Okay? And if you print at the end, the last example, you see that the lottery winner name, we put it equal to Jennifer. So if we print it, it will print Jennifer now and not nil anymore. Okay? All right, thanks for watching. See you guys in the next lecture.